Hello again, everyone, and welcome. My name is Geneva Langland, and I work with Michigan Sea Grant based in Ann Arbor, Michigan. I'm one of Michigan Sea Grant's representatives on the Great Lakes Sea Grant Crude Oil Transport Team, which includes Sea Grant programs from Minnesota in the west to New York and Vermont in the east. Welcome to our group's second webinar of 2020. The Crude Oil Transport webinar series is meant to provide the latest research and resources to stakeholders in the Great Lakes region to inform decision-making around this complicated and complex issue. Anyone with a vested interest in how crude oil and its associated products move throughout the region should find the content of today's webinar informative. Just a few logistics before we begin. This webinar is being recorded and will be available with captions on the Crude Oil Transport website at the URL you can see on your screen, greatlakescrudeoiltransport.org. It'll also be available on Michigan Sea Grant's YouTube channel. You attendees are invited to submit questions or comments through the question and answer box using the little icon down in your Zoom toolbar. If you also want to reach one of us panelists, you may use the chat function, but we prefer that you submit those through the question and answer box. Feel free to submit your questions at any time through the presentation. We will be collecting them for the Q&A session at the end. And we aim to end the webinar at 11:30. With all that said, it is now my pleasure to introduce today's speaker, Dr. Kristen Lewis. Dr. Lewis is the Principal Technical Advisor for Energy Analysis and Sustainability at the U.S. Department of Transportation Volpe Center. Her work focuses on resilience in transportation, alternative fuel transportation, availability and sustainability analyses, and environmental risk assessments. Dr. Lewis serves as the Head Research and Technical Advisor to the FAA-sponsored Commercial Aviation Alternative Fuels Initiative and provides technical expertise to the FAA as a member of the UN International Civil Aviation Organization Committee for Aviation Environmental Protection Fuels Task Group. I think that is the longest task group name that I've ever had the pleasure of reading off. And she also is the co-rapporteur of the Sustainability Certification Scheme Evaluation Group. Dr. Lewis leads the development of the Freight and Fuel Transportation Optimization Tool, a national model for assessing optimal transport of commodities in a supply chain, which is sponsored by the FAA, the Office of Naval Research, the Department of Energy, and the Federal Highway Administration. I am now going to stop my screen share so Kristen can get her presentation loaded up. She is here today to tell us about conceptualizing a risk-based hazardous material routing tool. And Kristen, I invite you to take it away.
Thank you so much, Geneva, and thanks so much to the Sea Grant Crude Oil team for inviting me today. I hopefully will have my screen sharing in a moment.
Looks like it's working on it and is on the way. Oh, there
Excellent.
we go. Perfect.
Great. All right. Thank you, everyone, for joining today. And thanks, Geneva, for the introduction. I really appreciate being able to be here to talk about this idea that we've been building toward developing a risk-based hazardous material routing tool, and particularly focusing on the challenge of routing hazardous material in the Great Lakes region as a case study to help direct the development of that tool. So I'm going to start just by talking a little bit about what a multi-criteria decision analysis tool is, and then why we might want one in this context. And then I'm going to give you an overview of the Freight and Fuel Transportation Optimization Tool, or FTOT, which is a tool we've been building for about the last 8 years. That is an example of this type of tool and something we might build off of and adapt to create such a risk-based hazardous material routing tool. And then talk a little bit about the conceptualization of that tool and some next steps. So what is a multi-criteria decision analysis tool? Well, this is actually a subdiscipline of operations research, and it's really meant to help a decision maker evaluate multiple conflicting criteria to select the best option. So it takes into account not just the individual criteria themselves, but also the values and the trade-offs between those criteria and how we make societal decisions about what's important given a range of criteria that we need to consider. It uses multiple mathematical value functions to reach the conclusion, but that has to be fed in by value definitions by the user or by the modelers. And as it turns out, there are a lot of existing decision-making programs and solvers that exist that can be adapted for particular problems. So while there's nothing that does exactly what we'll be talking about today, there are tools that can allow us to design something that will do the kind of evaluation that we're talking about. So why would we want a risk-based decision analysis tool for hazardous material movements? Well, as you all know, hazardous material movements pose risks to health, safety, and the environment. So there are multiple concerns that we might want to address. As far as we can tell, there is no publicly available tool that assesses the relative risk of different mode choices, different transport options for moving hazardous materials that take into account these different types of risks. And the current models that do exist, including the one that I'm going to show you today as an example, where we're focused on transportation options for freight, tend to focus on really concrete metrics that you might be more accustomed to, like the cost to move something, or maybe the emissions to move something, maybe the mileage, maybe the time to get there. Not focused on a risk-based orientation, but focused on these really discrete metrics that we usually use to think about routing. And that helps us optimize the mode choice and the routing choice for moving material. But it doesn't take into account the safety and other societal environmental risks in a comprehensive way. Now, we know that those risks are inherently complex and there are going to be trade-offs among priorities. You may not be able to come up with the best solution for protecting environmentally sensitive ecological communities and also protecting, human communities, or you might have other kinds of trade-offs that you need to think about. There are a variety of different aspects that may come into conflict with each other. And part of the process of coming up with a decision analysis tool is creating essentially a hierarchy and decision tree for figuring out how to navigate among those different risks. So the goal that we're working toward is to develop a software-based tool that will help analyze hazardous material transportation options based on not just those elements of cost and mileage and things like that, but also on multiple environmental, social, and economic risk criteria. So what I'd like to do now is introduce you to the Freight and Fuel Transportation Optimization tool. And as I mentioned, this is a tool that at Volpe we've been building for about the last 8 years. And as Geneva mentioned, this is a tool that has been sponsored by multiple federal agencies to help look at future scenarios for freight and fuel movements across the country and at regional scales. FTOT's really meant to be a flexible scenario testing tool that allows you to look at a lot of different types of commodities and a lot of different types of scenarios. So it provides a decision-making framework that the user can bring their information to. It's built on a geographic information system module that takes the network and connects that to the individual pieces related to the analysis. And then it brings that into an optimization unit that allocates the flows and routes the material in the scenario to maximize delivery and minimize cost. So in order to do this, we wanted to have a model that really takes into account multiple modes. Again, we're interested in that mode choice question. So we've built a multimodal network out of road, rail, waterway, pipeline for the commodities that can move on pipeline, and a set of multimodal facilities that connect them that allow you to move from one to the other, with the idea of then being able to add attributes to that network that determines the optimal routing and flow of material. So when we build a scenario in FTOT, we basically put in a set of origin locations and how much stuff is coming out of them, and a set of demand locations and how much stuff they want. And you can think of that as, a refinery that's producing fuels, and a destination, a fuel depot or a terminal or something where it needs to be delivered. It can be a range of those types of facilities. But one of the things that's unique about FTOT is it's actually a supply chain oriented approach. So we can look at something like crude oil coming out of particular locations, going to a refinery and transforming into something else and going downstream to its destination. So we look at a very holistic supply chain view to allow us to look at the implications for the change of commodities over the course of their movement. And when we run that scenario, we optimize the delivery and we allocate the flows. And what we get back is those material and commodity flows over the network, over every link in the network, the cost to move that material, the fuel burn, the number of vehicle trips it takes, how many barge loads, how many rail cars, how many truckloads, the distance that those vehicles travel, and the total distance on the network that's used, and their associated emissions. And we have released a public version of this tool, and I've put the link at the bottom here. It's a tool that you can download, you can play around with. We have some quick start scenarios you can try out that helps understand the capabilities of the tool, and you're very welcome to try those out and contact me afterward if you have questions. So the network that we've constructed for FTOT is, as I said, a multimodal network. We use publicly available data from the Federal Highway Administration for road. It's a freight analysis framework, the Federal Railroad All-Rail Network, the U.S. Army Corps' Inland and Coastal Waterways. And then for pipeline, we use the Energy Information Administration's data because it's not protected geospatial data. And we're able to use that and then adjust that to real station locations so that where you get on and off the network is accurately represented in the tool. And then we all have those multimodal facilities where you can transition between the different modes. So what we've done here is basically created a publicly available multimodal network that's flowable in GIS for those of you that work in GIS. And so, as I mentioned, we really take this supply chain oriented approach with this tool. So while we can do a fairly common type of scenario where you have a bunch of origins and you want to send them to a bunch of destinations, and we can flow that over the network and optimize it. But we also have the case where we might want to transform something from one thing to another, or at least aggregate it and modify it in some way. So this might be you have wood coming out of, trees coming out of a forest that are going to a chipper, that the wood is being chipped, the chips are going downstream to a biorefinery to make fuels, and the fuels are going downstream to various places. Because when we constructed this tool, we were looking at scenarios where we wanted to be able to accommodate scenarios where we might not know where that processing was going to take place. You can also do a variant on the scenario where you can generate candidate locations where you want something to happen. And these can be aggregation points. It doesn't need to transform at these locations, but the tool can actually take into account how you move stuff over the network to find the optimal solution and propose locations where processing facilities could exist, or aggregation points, or whatever it is that you need that in a broad way accommodate the material as it should be moving on the network to accommodate the supply chain needs. And then what we've really done is tried to make the tool as agnostic as possible about the types of commodities you move, the number of commodities that you move, and also incorporated a time element so that you can include things like schedule into the tool. And we can have variable steps in the supply chain. And so if you have multiple different ways that you're handling a material, you can have parallel supply chains moving through the tool at the same time. And this supply chain oriented approach is really something that we see as being unique to FTOT. We have not seen this in other tools, and could be particularly useful in the case where you have multiple steps that you want to take into account when you're looking at the movements of a particular material. So, as I mentioned earlier, when you think about risk-based optimization, there are a variety of things you might want to optimize on. What FTOT currently does is optimizes based on cost, but that cost is not just a straightforward, it costs me, 5 cents per ton mile to move something. It actually takes into account a number of different factors that sort of complicate the cost estimate. So we take the straight up transportation cost for road, rail, and water, that's a per ton mile cost. And then for pipeline, as it turns out, there are tariffs that designate the cost to move between specific origin and destination pairs. And you can't just get onto pipeline willy-nilly, and you can't just get off it willy-nilly. There are set origin destination pairs that you can use. So FTOT takes those into account and constrains the pattern of movement based on those origin destination pairs and applies the tariff when you move over it. But then we also take into account ways in which you would expect things to move or want things to move in the model. So we add what are called impedances or weightings to our network that basically apply an extra cost to things that you want to discourage, or maybe more appropriately, keep a lower cost for things you want to encourage. So an easy way to think about this is if you're moving something, 800 miles, you don't want to move it over agricultural roads or really small scale roads. You want to move them over the interstate if possible. So what the impedances do is make the base cost apply to the interstate. And then if you're on a smaller road, there's a slight incremental additional cost, and a smaller road, even than that, has an additional incremental cost. And we can tier that to almost indefinitely. So we can take into account multiple levels at which we want to encourage flows. And we actually do this on rail and waterway as well, where we encourage the movement of material in the patterns that the bulk of freight moves currently, because those are the most used corridors for a reason. Now, because we have these impedances and weightings that encourage things to flow in the way that you might expect them to or want them to, we also had to layer in capacity. And this is an optional path in FTOT where you can say, go the way that is best, least cost until that route is full, until it can take no more trucks or rail cars. Then you have to find another route. And FTOT can take that into account, and you can set the level of congestion you're willing to accommodate. And so we can take into account existing flows and the available capacity on a given link, and then FTOT will take that into account when it optimizes. Now, because we have the supply chain oriented approach, we can also take into account specific facility characteristics along the way. How small can they, or how little material can they take and still function? How much is the maximum amount of material they can take and still function? And if you are transforming your material like you would for, say, crude oil going to a refinery, what is the efficiency of that conversion, and what's the product suite coming out of that, and how much comes out for every given unit coming in? And so that's so that you can, or even if you're doing a storage facility, maybe there's loss at the storage facility, you can take into account that loss when you optimize the scenario, so that we can identify the final product that's moving over the network appropriately based on what's going in. And then the last thing I want to mention is the model that we have is really driven by the demand of the destination. If you don't want anything at the destination, there's no reason to move anything. But also, it's always cheapest not to move anything. So we have to apply a penalty for not meeting demand in the tool that drives the model. And what that does is it allows you to actually modulate that and play around with, well, what is it worth to move material over the network? Or if I'm willing to pay more for something or less, how much moves over the network? So that's the driver for the model. And I just want you to bear in mind that these are what we would call constraints in the optimization. So the ways in which we're doing this are really focused on the transportation related constraints. But this same kind of problem can be formulated to think about risks to other kinds of factors and be applied as weightings or impedances in the model, or applied as costs. And so the relevance of this approach is to the risk-based modeling is really appropriate. So what are we currently using FTOT for? Well, this is a tool that we started out creating for the national scale. but it is actually a scalable tool that you can drill down to the regional level. So we've done a lot of different analyses with the tool, and we have a lot of collaborators who are doing analyses with the tool. We've done national level analyses of future and current energy supply chains, for example. We've done similarly regional analyses of future fuel supply chains, what those might look like, how material might flow, how choices about where to supply that supply chain or where to process material, what those implications are for cost and allocation and use of the transport system. We've also been working with Federal Highways on regional analyses of freight to start thinking about how this tool applies to long-range planning for transportation infrastructure. So how do we decide, how do we understand how future transportation projects might intersect with a specific supply chain or generally with either a given commodity or a given freight flow, and think about how changes to the network can change that pattern. So this is something where you can start to test things like, well, what if we had an additional road link here? What if we had a different bridge? What if we had a different part of the network? How can we, what can we expect about how that will influence freight movements or specific commodity movement? We're also looking at those regional analyses of infrastructure changes more from a resilience perspective and thinking about, well, what happens when you disrupt the network because of either a particular foreseeable event or just in general wanting to look at potential disruptions of particular links in the network and how that would alter the pattern of flow and movement over the network. So we're trying to make FTOT as flexible as possible to look at these different scales and allow us to start thinking about the implications of our decisions on the transportation network for supply chain flows. So I wanted to show you an example of a national level analysis that we've done, and this is published, I put the DOI at the bottom, with the National Renewable Energy Lab, Department of Energy, and several academic institutions, as well as FAA provided the funding for it. And basically what this analysis was is looking at waste-based alternative jet fuel deployment and thinking about where it might be produced, how much might be produced, and what are the drivers that would get us there. And so the National Renewable Energy Lab used their biomass scenario model to look at different types of policies that would drive the deployment of alternative jet fuel over time, and basically looked at different policies and how the timeline for reaching 1 billion gallons of jet fuel would change if you applied different policies. And then what we did was we took a snapshot of that in 2030 and said, what are the what's the geospatial pattern that we could expect, and how would material flow over the transportation network? What would we expect from the transport of these fuels at this level? And so basically what we did was we looked at a proxy for these policies using that unmet demand penalty that I mentioned that drives the model. And we varied that unmet demand penalty and looked at how much material would flow and what the expectation would be for producing alternative fuels. And what you see here, and I'll just give a very high level view of this, is as you increase that demand, you see initially a lot of production in the Southeast and the upper Midwest, a little bit in the Pacific Northwest. Of course, as you increase the drivers for the scenario, you get a lot more delivery and you start to see a lot more movements on different modes. And so the outcomes of this particular study, again, were really focused on what it would take to get to 1 billion gallons of waste-based alternative jet fuel by 2030, and identified that it will require significant policy support and incentives, but FTOT really showed that it could be cost-effective to move close to 1 billion gallons of material, even in our low scenario. And in this case, while focused on waste and residues that are widely distributed across the US, the delivery and conversion are likely to be concentrated regionally, just like our delivery, conversion and delivery are currently aggregated in certain locations. And so based on our analysis, those likely locations were in the Midwest, Southeast, and the Pacific Northwest, and eventually Southern California. And to give you an example of a different type of analysis, this regional analysis, this is really an analysis that we did with Federal Highway Administration. In this case, we were looking at a specific supply chain that was of high importance for the region, which is sugar. And so basically in the region, they grow sugarcane in the parishes or the county level. They transfer that material to sugar mills, which turns it into raw sugar. Then that goes to a refinery, which converts it to refined sugar. And you also get sort of what's called bagasse, which is the cane waste from the raw sugar mills and molasses. You go to refined sugar, and then the end destination here for the refined sugar is the Port of Baton Rouge. And so we basically investigated this overall sugar supply chain, but also specifically looked at a subset of the supply chain for the Louisiana Sugarcane Cooperative, who were investigating the potential use of a rail line in their that has been defunct, that they were thinking about revitalizing, and they wanted to investigate what that would mean for the supply chain. And so what you can see on the left here is that the baseline scenario where everything's delivered by truck for this subset of the sugar supply chain. And then if we add this little rail link, you see a lot more material being moved by rail over the network instead of by road. And what we found was on an annual basis, if they added this rail link, it would replace 6,000 truckloads of molasses and raw sugar with 1,600 rail cars. And for the for the regional level planning commission that we were working with, this has implications for them in terms of road maintenance needs, congestion, and things like that. What we see too in the model is an increase in vehicle miles traveled because it's still cheaper to move over rail, even if you have to go further, and you reduce your fuel burn and CO2 emissions as well. So what we wanted to do with the crude oil movements in the Great Lakes and thinking about hazardous material movement is start thinking about how would we adapt this type of framework to a risk-based optimization, and what are the kinds of things we would need to think about. And so we started to develop a concept for how to move forward on this. Now, the first task we need to do is define the risks of concern. What are the challenges that are facing us when we try to move hazardous materials over the network? You know, what kinds of areas are we concerned about? What kinds of people or populations are of particular risk? And how do we quantify those risks? Then we need to think about, well, what's the relative importance or trade-off among those risks so we can create that hierarchy of decision-making. And this we would expect to be a particularly challenging aspect of the development, because this is the part that is that, you know, obviously lots of stakeholders are going to have concerns, and we're going to need to identify ways to prioritize different things or provide a range of options that one can use to define the importance and trade-offs. Then we need to figure out how we measure, how we indicate the severity of the risk of concern. So what's our metric that we use to basically inform the optimization? So if you think about in the case that I described to you earlier, where we have this optimization that's focused on cost, we transform all of our indicators, all of our constraints into the equivalent of cost, so that the tool knows basically how to minimize one thing, one currency, literally in this case, but one unit that it can then solve the problem for. So we need to identify indicators of the severity of the risk so that we can then translate that into some common metric that can then be used for the optimization. And so we need to, as I, indicate the metrics, and then we need to figure out, are the data available for these indicators? Do we know how to measure the risk? Do we have existing data that we can use that are geospatially explicit that we can apply to the network? Or that we can figure out how to take that geospatial information and translate it into a risk on the network, so that you know when you're passing over a given link what the risks are associated with that for a particular type of concern. Then we have to develop the optimization approach to figure out how to define the problem to minimize the risk based on that hierarchy. And then the goal would be to develop a transparent, geospatially explicit modeling approach that would help with this real world routing and optimization, again, with that goal of minimizing the environmental and social risk. So I want to give a shout out to the Sea Grant folks and also Jamie Weinbreg from the Rochester Institute of Technology and Craig Middlebrook from St. Lawrence Seaway, with whom worked to develop this initial concept and start thinking about how we could undertake this and bring people in to try and inform the process. And so this is something we've been thinking about for a couple years now, and we really hope that we can move it forward. We did do some brainstorming to think about, what are some of the risks we might want to take into account? What are some of the constraints we might want to take into account in such a risk-based analysis tool? Obviously, this is not an exhaustive list, and certainly there are a lot of nuances that would go into thinking about these risks, as I just mentioned, and defining them in more detail. But some of the things we might take into account still will be cost, time, distance, maybe fuel burn. How much fuel are you taking up to move the material? What is the risk of accident? Does it vary along the network? Can we quantify that? What's the risk if there is an accident of a spill? And then, what is the risk of pollutant emissions? And then once something like that were to happen, what are the areas that are sensitive to it? So ecologically sensitive areas for wildlife habitat or other sensitive environments. Other things we might consider are, can you get there? Can you get to the place that's high risk if there is an event? Is there availability of emergency response? Should that be a consideration when we think about how to route material to make sure that there is accessibility along the way? And then thinking about environmental justice or social vulnerability, what populations are particularly at risk, and what do we need to think about to mitigate that risk? And then there may be mode-specific risks. You are likely to have different risks or different levels of risk on different modes based on the characteristics of actually moving the material. And so if you can take into account those risks, that can help you make the mode choice decision as well as the routing decision. And again, we know that these are not an exhaustive list, and that there's a lot of challenge to figuring out actually how to take these risks into account. But this is just to give you a sense of some of the kinds of things you might want to take into account as a sort of jumping off point for brainstorming. And so our goal at this point is to figure out what we actually need to do with a scoping effort. And so our hope is to bring stakeholders together, hopefully folks on the phone, hopefully many other people who've been engaged in a variety of different efforts in this area, to undertake some of these challenges, to identify those risks of concern and figure out how we're going to measure them, figure out how we can get data that will allow us to figure out where that risk is highest on the network, and then discuss that optimization approach. And that would then set the stage for actually, adapting something like FTOT or a different model, or building a brand new de novo tool that would do this analysis for us and take into account these criteria. So right now, Sea Grant has been seeking to fund, and the partners have been seeking to fund that initial scoping meeting to convene the stakeholders, identify those risks, and scope the modeling approach. And so we do hope that if you are aware of people who, or agencies, organizations that might be interested in this, that you can connect us to them or provide contacts. And that is my contact information, but I've also got on here the key Sea Grant contacts who have been engaged in this work. So that is where we are at right now. This is still an incipient effort, but we really would like to gather support and gather people's interest, and also gather people's input. So with that, hopefully there will be some questions that we can answer in the chat, or at least some discussion or ideas that people want to raise and bring forward. So Thank you.
Excellent. Thank you so much, Kristen, for that presentation. We are finishing up a little early, so we've got lots of time to discuss, and we can always call it a little bit early if our discussion ends before 11:30, but we've got some questions coming in through the Q&A box. I will invite folks to continue sending those through at any point those come in. So here is a question about risk, particularly with maybe the crude oil transport side of things. You've listed some different categories of risk, and one person is wondering if the potential cleanup costs fit into any of those categories that you delineated.
Interesting question. So we had not included that in our list. That doesn't mean it shouldn't be in our list. And I think that is, you know, we had thought about that in terms of, well, if there's an incident, can you respond? But certainly the expected, so when you think about risk, there's the vulnerability, the potential that something will happen, and there's the severity, how bad will it be if it happens? And I think that cleanup cost could definitely be a part of the risk calculation, or it could be a separate constraint in the model where you know, it has its own estimate. The challenge would be estimating the cleanup costs for a given scenario. So depending on what you're moving and the volume moving and the location of an incident, you might be able to come up with some heuristic that would give you a high-level estimate of cleanup cost. The key is being able to apply it to the network. So you need to be able to say, if I have something happen here on this piece of the network, can I apply some risk to it? And that can be pretty broad brush, or it can be really detailed if you have detailed information. And so that would be the kind of thing that would be a great task for the scoping effort.
Certainly. Yeah, it's so hard to know exactly how to parse out all of the associated risks, but associated benefits with the sort of transport that we're discussing. We have one person who's wondering about the sort of functionality of the Q&A box. As people submit questions, those of us behind the scenes in the webinar get to see them, but those who submit them only see their own until a question gets answered. So you may look like you're sort of speaking into the void, but don't worry, there are other people asking questions. I just get to see them and read them out loud for you. So speaking, I guess, on the idea of risk, it seems like categorizing risk might be a good way to categorize risk might be to identify some economic benefits or costs of damages to a series of the most important risks. And I'll say that question comes from John Downing, who I know is pretty involved in this effort. And so he's wondering if that might be something that will fit into a joint request for proposals as this project potentially moves forward.
Yeah, I think that does make a lot of sense. And one thing that I didn't mention in the discussion, but you know, the other piece that you can put in there is things like benefits. You know, are there specific benefits to the movement itself or going over a particular link in terms of economics? And again, thinking about those trade-offs is really, you know, a lot of the crux of the matter too. Which risks do you prioritize when you have to make a decision between two options that, for example, where one has a higher risk of one issue and the other has a higher risk of the other issue? How do you make that decision? And I think thinking about costs and benefits is another lens on that issue.
Certainly, thank you for that answer. We have someone wondering, when we get to the sort of stakeholder involvement portion of scoping out a project like this, specifically for the crude oil transport one, how widely might we cast that net looking for stakeholder groups? And are there specific groups that we'd want to make sure we included?
Great question. And I think on some level, the Sea Grant team might be better positioned to answer some of that because of the range of stakeholders that are already engaged in the crude oil movements group and also the people who've engaged in some of the previous stakeholder efforts that have happened. But I would say that not only do we want regional stakeholders from the various types of organizations, including government and private industry and non-governmental organizations with particular concerns, but I think we also need to bear in mind that we would need to get perspective from other modelers who may have experience in these areas, or maybe people who are looking at parallel types of issues and questions who have experience in those areas. But maybe if John or any of the other Sea Grant folks want to weigh in about the efforts that have already been undertaken to reach out to stakeholders and some of the effort there, that would be welcome.
We do have anyone on the Sea Grant side who's interested in weighing in. I'll invite you to use the raise hand feature in Zoom, and I can go ahead and give you permission to speak, but there's no pressure there. That's just an open invitation. In the meantime, another question, maybe this one goes back more to the existing FTOT model. Was there any difficulty getting data from companies that are currently in the business of transporting materials? I know on a previous crude oil webinar, we talked about how hard it can be to get data from rail companies that are moving crude oil products, and how sometimes you have to sort of add some guesswork and as you're accounting for what might be moving where around the region. So was it any difficulty getting data to build that model?
Excellent question. And I think what that gets at is validation of the model. And that can be very challenging to try and get people to give data for a given scenario. I will say that while FTOT holds in the network existing aggregate flows and capacity, there's the sort of supply chain level information is really something the user brings to the scenario to construct the scenario. So for example, with the sugarcane work that we did, we spoke directly with the sugarcane co-op or the American Sugarcane League and got their input. And basically what we got from them was, the locations where they're producing, the locations where they're processing, the locations where they're sending stuff. And we did the optimization and said, is FTOT giving us an answer that's close, that is accurate for what actually happens? And we're able to tell us, yes, that's actually an accurate representation of how we move things over the network. But to your point, in the region, if you're looking at the Great Lakes region and you're looking at, say, crude oil movement or other hazardous materials movement, that certainly could be a challenge to try and get data. One thing that we can do, though, and that FTOT would allow, is basically coming up with a very general case where you basically, if you know approximately where material is coming from and approximately where it's going to, you can just put in the origin and destination and let FTOT choose how to flow it. And that's actually the point of the optimization analysis tool, would be able to say, if things were the best case scenario, how would we be moving this stuff if we need to get it from North Dakota to Chicago, or we need to get it across the Great Lakes region? How should we be moving it based on these risk criteria? And then that becomes a sort of vetting tool to say, well, is this how things are moving, or how can we start a conversation about this analysis that suggests this is the best the best path or the best paths and alternative paths based on specific conditions.
That's interesting. So a company wouldn't necessarily have to provide a bunch of data about its operations. You would be able to come to them and say, here is our analysis of what our model says is the best or most optimal way to do this. Does it match what you're already doing, or would you like to take any actions based on it? And then they have sort of the ability to do what they will. Is that
Right.
accurate?
Yeah, and you can also, so one thing we've done, for example, is we wanted to look at a network disruption for a specific bridge that is a bottleneck for freight when it shuts down, or even for passenger traffic. But when this bridge shuts down, the planning organization that works in this bridge area knew that people were having to reroute, but they didn't have a sense of what the implications were of that. And so basically what we did was we said, okay, approximately how much freight flows over this, over this bridge every day, or how much freight flows in the region. And we just took a number. It didn't need to be a specific number, because what we really wanted to know was, how does the flow change, at scale when this bridge is disrupted. So we took a number that was a reasonable estimate of how much freight flowed over this bridge. We took an origin point that was far enough out that there were multiple alternative paths. We took a destination point that was far enough away that there were many alternative paths. And the tool took the most direct route to start with. The baseline was flow over the bridge. Then we removed the bridge from the network, and we said, what happens? And we see where the reroute is. And we say, well, what if we remove a second bridge? What happens? And see where the reroute is and see what the implications are. What does it cost? How much further do you have to go to get, what's your best case? How far do you have to go? What are the change in emissions? What's the change in fuel burn? And those can be very useful ways of exploring the scenario, or playing around with. So if you think about a particular movement that would be like a risk-based analysis, you can do the same thing where you play around with the network. You can also play around with those risk metrics, or the level of risk that you assess, and see, like, well, if we could reduce the risk for such and such, then this mode becomes, or this path becomes more palatable, things like that. So it's a scenario exploration tool that gives you a lot of power to see how choices can influence the best path forward.
That makes me curious what the interface for the FTOT looks like. Is it just a bunch of numbers and equations? And when you're removing, for example, a bridge from the model, is it just deleting a number, or is it like a map that you can click and say, ignore this data point, and how would things move around? What's the interface actually look like?
So we don't, so the tool is publicly available, but it is what we would consider kind of an expert's tool. You have to be able to use GIS and Python in order to use the tool. And so if you want to modify the network, we have a network file, a geodatabase, and you can go in and remove the link. You can map it, or you can do it actually in a variety of different ways in ArcGIS, and then that gets fed into the tool, and the tool says, oh, this is my new network, and then it does the optimization. But there are a lot of different ways that you can modify the information that goes into the tool, and there are a lot of different ways to modify the network and the attributes on the network, which is what we call things like the impedance or existing flows, things like that. But generally, the short answer is you would do most of the network modification within ArcGIS. Okay.
So if anybody is curious about how to use this, you might want to go find a coding class and learn how to use some Esri products. But it is interesting to know that it's publicly available. Where do people find that?
So that is in GitHub, and it's, I don't know, are you going to share the PDF of the presentation? Actually, I'll just scroll back to it so you can see it, so people can see it.
Yeah, awesome. Yeah, the slides will be embedded as part of the video that we upload, but I'm not currently planning on sharing the slides separately.
Okay, so it might not be so convenient for people to find. So I'll leave this up so people can copy it down. It's at the bottom here.
I think it is perhaps having a hard time loading, or maybe you'll need to redo your screen share, because, oh, there it is. Never mind. It was being hidden by some gray boxes, but okay. So we've got the URL down at the bottom, which unfortunately the Zoom toolbar is trimming off a little bit. So maybe this is a good note. I will plan on uploading this PDF slide deck to the Great Lakes Sea Grant Crude Oil Transport website, where the video will also be housed. So if people want to find that link, they can access it that way.
Great, and also people are welcome if they email. I'm happy to send it out too. But it is on GitHub, and if you search FTOT, you should find it.
Okay.
So
So
the
we have,
code itself is
mhm.
open source. Sorry.
Okay. Oh yeah, go ahead.
No, I was just going to say the code itself is open source, as well as the documentation and the data to do basic scenario, to do your own scenarios. And if you have any issues or questions, you can always raise them on GitHub, or our contact information is also on the GitHub repository.
Sounds great. So we've got about 10 more minutes for questions. You're welcome to submit any more that come to mind through that question and answer box. We've got a couple more to go through that are already in the box. Has there been any interest from industry, especially oil companies, in further developing the crude oil transport tool? Or perhaps have they expressed interest in the FTOT as sort of a way of looking at crude oil transport?
So on the FTOT side, we have talked with several private sector entities that have been interested in either using it or, using the results from different scenarios. Because its initial genesis was focused on alternative fuels, a lot of the discussions we've had with the private sector have been focused around alternative fuels. And we do also collaborate with a number of different academic projects and others that are also in partnership with private sector stakeholders. Again, a lot of that has been on the alternative fuels side. And we've also had interest from private sector stakeholders who are focused on freight movements themselves and optimizing supply chain flows. We haven't talked with the fossil energy sector that I can recall.
Okay. So that'll be part of the scoping conversations if the crude oil transport model ends up moving forward, making sure that there's a need and figuring out how best to fulfill that need.
Right. But certainly our Department of Energy work was with policy office there, and that was focused on crude oil movements, and they certainly had an interest in the tool as a way to explore potential scenarios for crude oil. So hopefully that's an indicator that it would be of value.
Mm-hmm. So we talked a little bit earlier about the trade-offs between, the costs of transport, the benefits of transport. What kind of benefit transfer or cost transfer data does one need to consider? For example, if you're comparing and contrasting direct human costs with environmental costs of transport risk scenarios.
Yeah, and I think what I would say, and maybe this is punting a bit, but I would say that that's really something I think we need to figure out in this scoping effort. I think we need to really think about, how far out we assess costs and risks, and in terms of thinking about knock-on implications and things like that, and how those do or don't get folded into an analysis. Inevitably, you can't take into account every single risk and every nuance of that risk, but because it's a model, it has to be to some extent a simplification of the real world. But I think the scoping effort would really need to help to be executed to help us define, how we would assess those trade-offs, because that's really, and I think something like an MCDA tool, one of the values of it is that it would allow you to play around with those trade-offs and play around with the prioritization of different concerns, and identify sort of, when you change the hierarchy, how does that change the result?
Great. And we've got a raised hand from John Downing with Minnesota Sea Grant, and he is the one who asked that question. So I'm going to open him up to be able to talk. Right, John, you should be able to talk.
Great. Hey, thanks, Kristen, so much for this presentation. It was really terrific. I just wanted to clarify a bit what I was asking there. And it seems to me from what you've been saying that if we could estimate the economic cost benefit, if they're the same and sort of interchangeable in a way, if we could estimate those for a variety of different potential impacts, we'd have the ability to decide which of them are the most, well, there's the whole issue of risk versus cost and impact. So which are the most likely to be of high cost? I agree with you. You can't have everything in a model. And what we try to do is put the most high cost factors into a model, and those that are the most likely. And I think that, in a sense, maybe is what you're saying, that we need to try to figure out which are the ones to investigate, and for which ones do we need economic benefit or economic cost transfer data on, so that we can look at the cost of transport in parallel with the risk in terms of dollars or economic impact. I mean, reducing everything to a common currency is one way to do that. And that's what I was asking, was what do you think are the most important risks that the most important potential costs of, say, a spill that we need to be, say, putting into our RFP, or where do we actually need data? So that was what I was asking. I didn't ask it very clearly. So thank you so much for this today. It's been really beneficial. Thank you.
Thank you very much, John, and thanks for the clarification. My apologies that I didn't understand. And I agree with you. I think that we probably do need to prioritize certain elements that we can take into account. And some of that hopefully will be driven by their relative importance. And I think one of the challenges we have is figuring out how to translate things into a common currency so we can figure out which ones are the highest relative importance. And I have to say, I won't venture a guess at this point as to what those highest priority elements will be in terms of either cost or risk. So my apologies for that, but I really do feel like that's going to be a really crucial aspect of the scoping, is to figure out, how we're going to turn things into some sort of common measure. It doesn't have to be dollar cost, although it can be, but some sort of common measure or metric that we can use to optimize on. And I think that some of that will inevitably be driven by the data that we have available, but hopefully we can take into account a lot of the key concerns that people have and figure out a way to quantify that in a useful way for at least relative risk and severity. Sorry, I don't know that actually answered your question any further, but
yeah, it really did. That was great. Thank you.
All right. Well, thank you, Kristen, for that, and John for weighing in. That was a helpful clarification. We don't currently have any other questions waiting in the Q&A box, and we are almost up to 11:30. So I think, unless anything comes through in the next couple seconds, I think we are ready to call it for the day. Thank you so much to everyone for tuning in. Thank you to Kristen for that excellent presentation, and to all of you for your questions. We are in the planning stages for another webinar at least this summer, but we don't have a date yet attached to that. So keep an eye out for emails about future webinars and topics. This crude oil transport series. I think that is going to do it for us. Thank you again, Kristen, and I hope everyone has a great day.
thank you very much.